Okay, looking at number 2. Function f is differentiable on the closed interval -6 to 5. Satisfies f of -2 equals 7. Uh-oh, here we go. The graph of f prime, the derivative of f, consists of a semicircle and 3 line segments as shown in the figure. So this is the graph of f prime. So they do not want us to miss the fact that this is f prime, not f. So we'll have to be super careful when they're asking us questions that this is f prime, not f. Find the values f of -6 and f of 5. Okay, f of -6. So I want to find f of -6, but I don't have f, right? It may be tempting to say f of -6 is 2, but that's not true. F prime of -6 is 2. That's not what I want, though. So if I have the graph of f prime, and I want to get from f prime to f, how do I get from f prime to f? What's that? The antiderivative. So I need the antiderivative of f prime. That will get me back to f. Antiderivative. Remember, that symbol means 2 things. It means antiderivative of an equation. But what else does it mean? Area. And if we do area, we have to have limits. So what would be a good limit to use, especially if I want to find f of -6? Definitely -6. And what else? What other x value should we use? -2. So let's go in order here. Let's go from -6 to -2. So that would give me f of -2 minus f of -6. Okay, so how am I going to evaluate the antiderivative of f prime from -6 to -2? What is that? How do I find that? Count the squares? Yeah, I mean, I don't know that I could count the squares on this one, but yes, area. So let's see. Let's be careful here. Let's see. That's 4 wide by 2 high. So half of 4 times 2 is 4. F of -2 they gave us. And we're trying to find f of -6. So we move things around. F of -6 equals 7 minus 4. And just because I want to be cute, I can leave that as my answer. Right? Probably not going to mess up 7 minus 4, but just as a little wink to the grader of, hey, I know what safe stops are. Why don't you figure out 7 minus 4? F of 5 is going to be almost the same thing. The same type thing, anyway. Integral from, let's see, I'll need to use 5 and -2, so we'll go from -2 to 5 this time. Of f prime equals f of 5 minus f of -2. We know f of -2. We're trying to find f of 5. So once again, we need area from -2 to 5. What makes this one a little trickier, maybe? There's a semicircle. That's harder than a triangle. But what else? The semicircle is negative. So we'll be careful here. So let's see. That area, I'm going to label it negative. Be careful. I think they mentioned this in the last video. Like, your words matter. Like, the area isn't negative, but the antiderivative is negative. So let's be careful. I'm just going to label it negative and not call it area, even though that's what it is. Let's see. Half of pi r squared f of pi times 4, that's negative 2 pi. Again, the area is 2 pi, but it's underneath, so we'll use negative 2 pi. 1, 2, 3, 4, 5. Okay, so I need all of that second triangle over there. Base times height divided by 2, that area is 3. So the area is negative 2 pi plus 3. That equals f of 5 minus 7. Is that a safe stop?
No, you just said you want
I have to solve for f of 5. I haven't said f of 5 equals yet, so that's not a safe stop. Almost a safe stop. We're going to move the 7 over. And at this point, I'm just being, I don't know, rude, whatever. But safe stop. Move the 7 over. Now I'm good because I've solved for f of 5. So that's part A. All right, part B. On what intervals is f increasing? Justify your answer. I don't know if it's always, but almost always when you see justify, you should probably justify first, because then you'll know what you're looking for. So let's justify first. F is increasing when, so not for this particular problem, but just in general, when is F increasing? What would I be looking for? F prime is positive. F prime is positive. Okay, there's my justify point right there. So now I just need to look and see, and that should make my answer easy now. I'm just going to look in the graph and see where f prime is positive. This is the graph of f prime. What am I looking for? How do I know when f prime is positive? When it's above the x-axis. So that would be from negative 6 to negative 2. And then from 2 to 5. So that was an easy one. As long as you remembered to justify first, that tells you what you're looking for, and then you're good. Part C. Find the absolute minimum of f between negative 6 and 5. Justify your answer. Okay, absolute minimum, especially the absolute part, should trigger a word or trigger something in my brain. Do you know what we need to be worried about for absolute minimums? We got to check the endpoints. Check endpoints. It's not really part of the answer. That's more like note to self. Check the endpoints. And any local minimum. Okay. Check the endpoints and any local minimums. So the endpoints are negative 6 and 5. Oh, that's nice. Because we already found f of negative 6 and f of 5. So f of negative 6, oh, I was being cute earlier, but I probably need to go ahead and say 7 minus 4 is 3. And f of 5 is 10 minus 2 pi. Let's see, 10 minus 2 pi, that's 10 minus 6, that's 4-ish. So negative 6, 3 is the smaller of those two, but I need to look for any local minimum. Let's see, that would be where f prime changes. F prime changes from negative to positive. So I look at my picture. So at what value does f prime change from negative to positive? At 2. At 2. Okay, so the fancy word for what I'm doing is the candidates test, but you don't have to know the name for that. I'm checking out the candidates and see who's got the lowest. The endpoints and the local minimum. So I need f of 2. Now they're going to make me find one more here. So the integral of f prime from negative 2 to 2. So I've already done this for 5 and negative 6, but now I've got to do it for 2 because that might be our absolute minimum. Okay, we already did this, like we already know that area is negative 2 pi. F of 2 is what we're looking for. F of negative 2 is 7. So f of 2 is 7 minus 2 pi. Okay, and I'm looking for the absolute minimum value. Okay, so which one of those is the smallest value? I don't have a calculator, but they made them different enough. Yeah, 7 minus 2 pi is 1-ish. That one's 3, that one's 4. So the absolute minimum is, now am I going to report the x value or the y value? Which one's the minimum? The y value. So the absolute minimum is 7 minus 2 pi. It occurs at x equals 2, but it didn't even ask me for that. Absolute minimum is 7 minus 2 pi. And it says justify your answer, but the candidates test, that table of values is the justification, especially if I've spelled out that I'm checking the endpoints and any local minimum. So I've justified that. All right, part D, last part, so this is probably where we're going to earn our 5 if we can figure out part D. For each of f double prime of negative 5 and f double prime of 3, whoops, not negative 3, find the value or explain why it doesn't exist. I haven't done this problem in a long time, but since they gave me 2 of them, I'm going to guess that one of them exists and one of them doesn't, but we'll see. So how do I get f double prime if I'm looking at the graph of f prime? Slope. So this is the slope of f prime at x equals negative 5. Okay, well that's an easy one. Well, I've got to figure out what the slope is, but let's see. Here's negative 5. That slope looks like it goes down 2 and over 1, 2, 3, 4. Yes, that reduces, but no, I don't have to reduce it. So the second derivative at negative 5 is the slope of the first derivative is negative 2/4. F double prime at 3 is the slope of f prime at x equals 3. What's the slope of f prime at x equals 3? Why doesn't it exist? There we go. And so it kind of happened like we thought it would happen. One of them worked and one of them didn't. So it does not exist because there's a cusp. Man, that's a problem that you should get all 9 points on. Like that was a... You hope you get a couple where you get all 9, and then you just fight and claw for everything you can get on the others, and then hopefully that's enough for a 4 or a 5 on the AP test. Oh, perfect. Look at the timing. It just hit 15 minutes. You're supposed to take 15 minutes per free response question. We took 15 minutes, and that was me going slow, explaining, drawing pictures, reminding you of things. So, yeah, timing was perfect on that one. Okay, so your job is 1 through 3. 1 is posted on video online. I'll show you in a minute, remind you where it is. We just did 2, and so that just leaves you with number 3. See if I can find that video. So review videos. Spring 2024. I'm pointing at it. You can see where I'm pointing. There's FRQ2, number 1. So you can try it on your own, or you could just watch me do it, whichever you like.